Good morning. Colored pens up. So let's see how we did. Equity bars are in effect this morning. Stay on your toes. We're going to get as many people involved as possible. We are on number one and number one only. Question number one, I've got students 18, 9, 5, and 1. Student 18, 9, 5, and 1. Student number 18, what'd you get?
X is greater than 4.
Okay, student number 9.
X is greater than 4.
So you two agree. Student number 5.
X is greater than 4.
3 people agree. Student number 1.
X is greater than 4.
X is greater than 4. Very good. Number 2. Let's see how we did. Student number 2. Question number 2. I got student number 17, 4, 13, and 16. Student number 17. What'd you get?
X is greater than 2.
Okay. Student number 4.
X is greater than 1.
Okay. So we have a disagreement. Student number 13. What'd you get? Okay. Student number 16. What'd you get? Oh, is that what you said, Matthew? 3 over 2? I misunderstood you when you said it. I apologize. So it is the same thing, of course. X is greater than 1 1/2. So we did not do any questions like this. So you guys were able to extrapolate what you've learned and apply it to something new. Very good job. Anyone have any comments or questions about today's warm-up? And now we've got our brains working in the right gear. Okay, last time we were together, we started exploring the use of inequalities within one triangle. Today we're going to expand to how inequalities can be used to work with 2 triangles. You should have your cheat sheet out. You're going to need it. You should pretty much just be taking it out no matter what. And our objective today is to be able to apply inequalities in 2 triangles. And there's no new vocabulary. We're going to utilize all the vocabulary we've been using all year. So, I do not want you to write anything. I don't want you to copy anything. This part of the lesson is an observation and an exploration. So I have 3 pictures up here. I've masked one of them. And it's a picture of a classic wooden fence with a wooden gate. But what I want you to notice is what happens when the gate opens more or less. You can form a triangle from the doorway, the base of the door, and then the opening, the space of the opening. So you see that we've drawn a triangle, ABC, from these spaces or lines. And then we've drawn another one labeled ABC here. You should be able to tell that this door, even though it's a 2-dimensional picture, it's supposed to be depicting 3D. This door is open more. How does a door open? What mechanism allows a door to open? If I walk over here, I turn this handle, what allows me to do that? What allows me to do that, Kamoy? Hinges. And so it's a little bit hard to see because the picture didn't reproduce that great, but there's a hinge here and a hinge here. And this is the same picture. My door has 3 hinges. It's a heavier door, 3 hinges. So the door swings on the hinges, and what you will see is something interesting happens. See AB in both pictures? What could you tell me about AB in both pictures? Kadir? It's the same. Because it's the same exact picture, it's the same gate. The doorway doesn't change. Does my doorway ever get bigger or smaller? No, it's always the same. Now look at AC. Now here's where the picture is a little bit messed up because of the fact that it's trying to depict 3D. But what should be true about AC in both pictures? Nathaniel? AC? Well, it looks like it gets shorter, but this is a door made out of wood. So when I swing it open, does that really change? Okay, so I apologize because it is based on the picture. The artist tried to make it look 3D. But we're talking about, if you could look over here, the bottom of the door. Does it change when I do that? If I measure it here, or here, or here, or here, won't it be the same? So the only thing that changes is this distance, BC. BC changes depending on how far open, how wide the opening is of the door. And we can see it yet again in my third picture right here. Now my classroom doorway, it can't do this because there's a wall there. However, this can swing open beyond perpendicular, and you can see that BC gets even bigger, even though the doorway and the door itself do not change. And this idea and what Kamoy said earlier leads us to today's major idea, which is the hinge theorem. Now, remember that cheat sheet is a good news, bad news. Cheat sheet is good news because I've saved you tons of time in writing. The bad news is that sometimes writing things, actually often writing things, helps you. So you're going to have to make up for that with some effort and concentration. So the hinge theorem is when you have two triangles. Last time we were together, we explored theorems that involved one triangle. Theorem 5.10, 5.11. That was only one triangle. Now we're talking about two. If we have two sets of congruent sides, so we have, here's one set, and here's another set, and the included angle of one is bigger than the included angle of the other, then the third side will be longer than the third side of the other. So we're talking really about what happens to this. So you can see in this statement, Wx is greater than St. Notice that there's no bar over it because we're talking about values, we're talking about distances. So Wx is greater than St because this angle is greater than that one, and these are congruent. That is the hinge theorem. Anyone have any questions about that? The converse is also true. If we have two triangles that have two pairs of congruent sides, here, 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 and here, but now the converse, now we have sides, third side is longer than this third side, then we can say that this angle is greater than this angle. And you see that expressed in this statement right here. So that's converse of the hinge theorem. From now on, I'm just going to say the hinge theorem, but sometimes I'll be referring to the converse, sometimes I'll be referring to the original form. So does anyone have any questions on the basics of the hinge theorem or the converse? So now look at your cheat sheet. I believe we're on the back of it. You should be able to see now all the theorems from the past two lessons. Theorem 5.10, 5.11, the triangle inequality theorem, the hinge theorem, and the converse. The first three apply to one triangle. These two new ones apply to two triangles. You have to be able to keep that straight. Okay? Any comments or questions? So let's start exploring some different scenarios and see what we can figure out, what we can learn, etc. Most of the pictures you can just sketch. I'll tell you if you need a more elaborate or more detailed picture. So this can be a sketch. Now, in the previous chapter, we spent a lot of time learning how to prove two triangles were congruent. We learned all different methods: side, angle, side, angle, side, angle, 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 side, hypotenuse, leg. Now we're talking about something similar, but we're not talking about congruence. We're talking about what we can say about a third side based on some evidence. But that's the parallel that I want to draw. That in chapter 4, we spent a huge amount of time talking about gathering evidence. And so we're back to that again. So example 1a, we're asked to compare two angles, BAC and DAC. So we're asked to compare this angle here and this angle here. Compare it. What can we say about them? So let's gather some evidence, and I've already given you a clue that we want to explore the hinge theorem. So let's gather some evidence. Well, here's some evidence right here. What can we say about AB and AD? What can we say about those two sides? John? Okay, so they are congruent, okay? So to use the hinge theorem, we need two pairs of congruent sides. We have one pair, so we can't use the hinge theorem. Any thoughts, any concerns, any observations? Oh, some light bulbs gone off. Stephanie, how do you know that? Beautifully said. This is the second pair of congruent sides because it's congruent to itself because of the reflexive property. And so now we can use the converse of the hinge theorem because we see that this is 7 and this is 6. So that immediately tells us something about this angle versus this one. So what could you say about the two angles? What statement can you make about the two angles? Just a few people can make statements. Okay, let me ask it differently. Give me a thumbs up if you know something about those two angles now. Okay, good. Okay, John, go ahead. You were on a roll. Very good. The measure of angle BAC is greater than the measure of angle DAC. And so that is a comparison. And we know it to be true because of the hinge theorem, the converse of the hinge theorem in this case. Does anyone have any questions on how we came to that conclusion? We gathered evidence, and then we made a statement. Any questions? Good, let's continue exploring. In 1b, now we have a new picture and a sketch, again, will be good enough. Again, we are attempting to explore the hinge theorem. So I've kind of given that away. I've let the cat out of the bag. We want to use the hinge theorem. So gather some evidence. I'll give you a moment to finish copying. We're drawing a sketch. So what evidence do we have? Can someone give us something? Go ahead, Alexandra. Very good. EH and GH are congruent because of this right here. Beautifully said. But to use the hinge theorem, we need two pairs of congruent sides. That's one pair. Can we find another pair? Stephen? How do you know that? The reflexive property. Very good. Now we want to use the hinge theorem, which means we need the included angle. And so we have an included angle here, but I don't have anything to compare it to over here. I don't have another angle. So what are we going to do about that? Cherie?
We can use the linear pair postulate thing to since we know then that since they both two of the angles equals 180, we can subtract 82 by 180 to find the other angle.
Very good. The linear pair postulate thingy? That's pretty good. You could just say linear pair postulate if you'd like. Yeah, he's absolutely right. That's a linear pair. The linear pair postulate says that they're supplementary, so we can subtract 82 from 180, and what do we get as the second angle? You can do mental math or use your calculator. Come on. It's going to be 98 degrees. 98 degrees. Very good. So now we have all the evidence we need to use the hinge theorem. We are asked to compare EF, which is this side, this distance, to FG. So now we have all the evidence we need. What statement can we make about those two lengths? Nathaniel? You can say FG is greater than EF. Of course, you can flip it around and say EF is less than FG. Either way, it's the same thing. Absolutely. And that is based on the hinge theorem. So we got the basics down. Anyone have any comments or questions about the basics of the hinge theorem? Well, we're in geometry honors, so let's take it to the next level and explore a slightly more complex scenario. And again, a sketch will be sufficient. So now we're asked for something a little bit different. Find a range of values for k. In other words, what numbers can we put right here that will make this work? So I'm going to do a couple of the parts quickly so we can use our time well. We have some evidence here. So we have a pair of congruent sides. And then Stephen would tell us that Ln is congruent to itself. So we have another pair of congruent sides. And then we have this 19 and this 18. So the converse of the hinge theorem is now in effect because we have these distances right here. That tells us something about these two angles. What does it tell us about the two angles? This is 19 and this is 18, and we have the congruence. What does it tell us about this angle and this angle? Kadir?
5k minus 12 is less than 38.
Yeah, this angle must be smaller than this one because this side is smaller than this one. So we can say 5k minus 12 must be less than 38, and that's going to help us find this range of values when we solve them. So go ahead and solve it. You can do that. Some of you could do it mentally, some of you can do it quickly. You did it? Oh. So we end up with k is less than what? K is less than what? Valid? 10. K is less than 10. But we were asked for a range of values, and we explored last year, and we've seen this year already. The range of values looks like this. We can already see that k must be less than 10, so I can already see that the 10 must go here. But now we're missing something from over there. We have to figure it out. So you've got a minute of team talk. See if you can figure out together how to get the other number. Or take a moment for yourself to explore.
We have to find something that
Well, not necessarily, because one of the answers is the increase to zero. So we can set one as equal to zero, and then that's the increase. To confuse it. Presents that as equal to zero.
I know it's at
Because it's zero.
zero.
Zero, right.
I mean,
Fine, solve it, and then the answer is what goes here. Anything above this was, anything is that.
Okay, so I heard some pretty profound things come out of my students' mouths. That was pretty great. In 1 minute. Someone over here said, well, let's just put a 0. Someone else had a great response to that. John, what was your response to that?
I said we should set it less than 0 and solve it.
Well, okay, but even before that, someone's proposed just putting a 0 right here, and you said you can't. What was the reason that you said?
Because it'd be -12.
Yeah, if you put a 0 there, then that would be -12, and that doesn't make any sense. So you cannot just put a 0 there. And then the discussion continued, and then they figured out, go ahead, John, you came up with what?
I said put 5k minus 12 less than 0.
Is less than 0?
No, I mean,
Equal to 0?
yeah, I put
You put equal to 0? Okay. What should it be? He's right, there's going to be a 0 here. What should it be in between? Because we're talking about an angle, right? This angle, can it be equal to 0? If it's equal to 0, what does that mean? I love the way you said it's not even an angle. So what do we need to put right here? I heard someone whisper it already. What do we need to put there? Can't say it any louder? Yeah, it needs to be greater than. It has to be greater than 0. So once we establish that, we solve that, we end up with a value that will give us the range. And I already heard someone tell us what it solves to. What does it come out to, Sharif?
2.4.
Comes out to 2.4 or 2 2/5, doesn't really matter. And so we get this range of values. And remember, there's no bar here. So k cannot be equal to these values. K has to be greater than 2.4. So it could be 2.41. It could be 2.44. It could be 2.5, 2.6, 2.8, 3, all the way up to 9.999999. It cannot be equal to 10. Because if it's equal to 10, that would make this a 38, which cannot possibly be because this side is smaller than this one. So it cannot be equal to 10, it has to be less than 10. And it cannot be equal to 2.4, it has to be greater than 2.4. Does anyone have any questions on how we got that range of values? Okay, you guys are doing very well. I was very impressed with that quick team talk. So now checkpoint number 1. I've given you 2 things to explore. So you got 2 minutes. You do not have to draw anything for checkpoint. Just need to find me an answer to demonstrate that you're starting to understand what's going on. All right, so let's see how we did. When I call on you, you tell me the statement that you wrote. For part A, I've got student 18 and student 9. Student 18, what did you write?
Measure of angle EGF is greater than measure of angle
Okay, and student number 9, what did you write?
Angle EGH is less than angle EGF.
Okay, so I think we said the same thing in 2 different ways. So you could say the measure of angle EGH is less than, or you could say the measure of EGF is greater than. Either way is fine. And for part B, compare BC and AB. You've got student 16 and student 14. Student number 16, what did you put?
Measure of
Okay. What was the first one? A, B. Okay. Student number 14, what'd you put?
Segment BC is greater than segment AB.
BC is greater than AB. Okay, so that was 2 different things. So, yeah. So, Stephanie, you misunderstood a little bit. In this case, we were not exploring the angles. We can see those angles right here. The measurements are given to us. So I'm not sure if that's what you were talking about or what or if you were looking at these angles here, but we were talking about two lengths. Okay? You see now what we were talking about? Okay. Any comments or questions about checkpoint number 1? No comments or questions? Okay, so now apply it to something a little more real. Something a little more real. You do not need to copy the text, but you need to sketch the picture. And here's what I want you to do. Listen before you start. I want you to sketch this picture. I want you to read, and then I want you to take the information from the text and put it into the picture. Make sure you do it correctly. After you're done, compare your picture with your teammates. You got 2 minutes to do that. Draw the picture and put in the information. And I have to change one thing. This should say southeast.
Oh, school.
Okay, I'm going to restart the clock. It's kind of funny because the exact same thing happened with the other class. Is that it took everyone about a minute and a half to figure out what was going on. So let's start this again. They leave school.
Oh.
Oh, we're still having light bulbs go off. Okay, yes, they're leaving school.
Yes. Yes.
So what happened all the way out there? So he's already got the house. So why did he?
Oh, that is pretty funny.
He's like
Oh.
that means very seldom, that means they went further. So this is like the factors
Okay, so let's see if we can figure some things out. So we have two characters in the story, John and his cousin Luke. And John rides his bike 3 blocks west. So I'll start us off. This is the school. West is this way. So John rides 3 blocks to the west. Then turns, sometimes they'll say due north, meaning perfectly north. So turns perfectly north and travels 4 blocks. What can you tell me about this right here? What can you tell me about that, Kamoy? Yeah, see, you know what you're talking about. Mhm. So now, cousin Luke is going in the other direction. Could someone tell me what distance is that right there? Nathaniel? 4 blocks. So here's the 4. So now, what is this distance here that gets us to Luke's location? Eric? 3. So what can you tell me about this angle right there? What is that angle? Go ahead, Eric, you're on a roll.
100 degrees.
That is 100 degrees. It's 100 degrees because he is turning at a bearing of 10 degrees southeast. Okay? Going perfectly due south would be more like this, and that would make that a 90-degree angle. He's going 10 degrees more than that, that makes that a 100-degree angle. Okay? So now the question is, who is farther from school? So the question is, which of these distances is longer? Which is longer, and who is further from school? Go ahead, John.
Luke's line is farther.
Luke is further from school, but why?
Because since it's 100 degrees, the Hinge theorem says if it has a higher degrees than the other triangle, then the line's going to be longer.
That's right. That was a great explanation. We have congruence. We have the evidence. 4 and 4 and 3 and 3. Even though the triangle is turned a little bit, it's still 2 congruent sides, and we have the included angle. This one's 90, this one's 100. This is bigger, which means the opposite side is going to be bigger. That's the Hinge theorem. So from the Hinge theorem, we can say that Luke is further away because of the Hinge theorem. Any questions about that? Any concerns about that? Okay, so let's see if you can apply it to this scenario. And you do not have to copy anything, but I want to clarify just a couple of things because the picture did not translate as well as I had hoped. Give me a thumbs up if you've ever been on a ride at a carnival or at an amusement park that's usually called the swings or something like that, where you're on a swing that's hanging by a chain and it spins around, and the more it spins, the further out you go, and you feel like you're flying a little bit. Great ride. I went on it as a kid. Great adventure in New Jersey. I've been on it. There's a carnival that comes here to Coral Springs. I went on it here. So I'm glad to see some of you who've gone on it. So in this is a picture of it and a description of what happens with this ride. So now, keeping that in mind, I want you to answer the question. What can you conclude about the angles of the swings at full speed versus low speed? What can you conclude? You got 2 minutes. Make sure you have evidence to explain. right. What can you conclude about the angle at full speed versus low speed? Stay on your toes. Here we go. What do you have to say? Student number 4, 1, 21, and 14. Student number 4, what do you have to say?
The angle of the person, like the top of the pole, it gets wider as it goes.
Okay, student number 1, what do you say?
The angles are larger. The angle are larger at the full speed and smaller at the slow speed.
Okay, student number 21. Student number 14.
The angle of the swing at high speed is larger than the speed at low speed.
Okay, why, Eric?
The converse of the hinge.
Okay, so the converse of the hinge theorem. Okay. Do we have the evidence to support that? We need two pairs of congruent sides. Where are the congruent sides? Valerie? Okay, you said that beautifully. The height of the pole is one pair of congruent sides, and the chain is the other pair of congruent sides. That's not going to change. But we can see from the picture that this is a greater distance than this one, and that means that this angle is going to be greater than this one. So you had to have the evidence to support it. Great job. So I wrote something a little more elaborate, that the angle of the swing at full speed is greater than that at low speed. But basically you guys said the same thing. Anyone have any comments or questions about checkpoint number 2? Okay, so like we did in chapter 4 when we were learning how to apply things to proof, we're going to do that here. And we're going to explore how to prove something using this these new evidence techniques that we have. And I have a typo here. This is supposed to say AD. Sorry about that. So we want a 2-column proof. So we've talked a lot about proofs and how to approach them. I've encouraged you to do a few things, to think about your path or chain of logic, and in some cases, trying to figure out what the last step or the second to last step is going to say so that you can find the evidence working backwards. Sometimes that works, sometimes it's not as useful. Since this is a little new for us, we're not going to go backwards, we're going to go forwards and see where it leads us. So what do you think we should start with? What should we start with, Alexandra? Given? That's a nice, safe place to start. Let's go ahead and just start there. That segment AB is congruent to segment CD. And it's given that the measure of ABD is greater than the measure of CDB. And that's, as far as proof is concerned, that's something we're not used to. We're used to congruent statements. We're not used to inequalities in proofs. So here's something that's a little bit different. And that, of course, is given, as she said. But remember, your job when writing a proof is you are a geometry detective. You are gathering evidence. We've been exploring the hinge theorem. this is the last statement. What do you think the reason is going to be for that last statement? Right? All the way down here somewhere down here, it's going to say AD is greater than CB, and then there's going to be a reason. What do you think the reason is going to be? Come on. The hinge theorem. So we want to be able to say this because of the hinge theorem. And so the hinge theorem requires evidence. Do we have all the evidence that we need? Do we have any of the evidence that we need? Can someone tell me one of the pieces of evidence that we have to use the hinge theorem? Nathaniel? Okay. Say that again, I'm sorry.
ED is congruent to BD.
Oh, okay. So that's not listed yet. So you're saying that this is congruent to itself based on what?
The reflexive property.
Okay, so now he's just gathered a new piece of evidence that BD is congruent to BD because of the reflexive property. Remember, it's the reflexive property of congruence, but we just get away with reflexive property. So that's one piece of evidence. How many pieces of evidence do we need to use the hinge theorem?
2, 3, 4, no, 3.
Okay, well, it's kind of two, it's really three, but so we have one. What's another one, Sharif?
Well, the BD is one. There's another one which is the segment AB is congruent to segment CD.
Okay, so there's the second piece of evidence. So we've got one piece of evidence right there. We've got another piece of evidence right there. So we're missing the third one. What's the third piece of evidence that we need for the hinge theorem to work? Look back at the cheat sheet. What's in the hinge theorem? John?
The measures of
The angles, that's right. So how do we get that piece of evidence?
it said in the given it says that angle ABD is greater than measure of angle CDB.
Yeah, we actually already have the piece of evidence right there. We have all three pieces of evidence. We had to do what Nathaniel did. We had to create that second piece of evidence. Now we have all three pieces. Now we can say the proved statement. AD is greater than CB because of the hinge theorem. But you can't write that until you have demonstrated the three pieces of evidence required. If you want to use the converse of the hinge theorem, then you need the lengths of, you need to prove congruence of two sides, and you need the lengths of the third side. Or a statement like this saying that one side is greater than the other. But no matter what, using the hinge theorem or the converse, you need three pieces of evidence. You guys thought it was going to be like a really long proof, right? Simple little proof, right? I mean, you guys have done much more challenging proofs, so you guys did a good job. Does anyone have any questions or comments on how to incorporate the hinge theorem into doing a proof? I had a little bit more planned, but I'm happy with what we've done. So your homework tonight is page 340, numbers 3 through 10, numbers 14 through 18, and number 22. It works out to a total of 14 points, it's just 14 questions. Start utilizing the interactive practice tests or quizzes online because you have your Chapter 5 test on Friday.